Hello everyone, welcome back to my channel. Today's topic will be peritoneum and it is the second part before I have explained the greater and lesser sac. So let's start. So peritoneum is a thin serous membrane and lines the walls of the abdominal cavity and viscera. The one which lines the abdominal wall is parietal peritoneum. The one which invests the abdominal viscera is visceral, and the parietal receives somatic afferents, therefore the pain is well localized, while the visceral peritoneum receives autonomic nerves, therefore the pain is poorly localized. So this is a simple diagram to represent the parietal peritoneum, the visceral peritoneum around the organs, and in between them there is a peritoneal cavity, and also there is a mesentery or the folds of peritoneum that attach the organs to the posterior abdominal wall. So peritoneal cavity, it is a potential space. It normally contains only 50 ml and the organs don't actually lie in this space. And in males it is completely closed, while in females it communicates with the exterior body via the uterine tubes. So the organs are kind of projected into the peritoneum. If you have watched my previous video, you know exactly what I'm talking about. So the organs which are completely surrounded by the peritoneum are called the intraperitoneal organs, and they are attached to the body wall by mesenteries, which I showed you in the previous picture. So these are liver, spleen, stomach, first part of duodenum, jejunum, ileum, transverse colon, sigmoid colon, and superior rectum. Now it is easy to understand this with the picture, and I have explained this picture in my previous video. Here you can see the liver, the stomach, the transverse colon. They are completely surrounded by the peritoneum and they are attached to the abdominal wall by mesentery or mesocolon. So this was about the intraperitoneal organs. Now, primary retroperitoneal organs. Retro means behind. So primary means the organs which are developed and remain behind the parietal peritoneum. And this is only kidneys. And this is a beautiful picture by Netters. You can see it is covered by the peritoneum. The organs have been removed, so you can have a better idea. Secondary retroperitoneal organs. They were developed first with a short mesentery, but then they became retroperitoneal. And the examples are adrenal gland, pancreas, 2 to 4 part of duodenum, ascending and descending colon. And let's look at this. So pancreas developed a short mesentery, but then it was pushed backwards due to developing organs or other such changes, and you can see it became retroperitoneum, but just a small area of pancreas, that is the tail of pancreas, is still intraperitoneum. And we have this mnemonic by the first aid, Sad-Pucker. Here you can see all the organs. The suprarenal gland, obviously if the kidney is retroperitoneal, most probably the suprarenal gland are also retroperitoneal. Aorta and inferior vena cava, they are posteriorly, they are quite posterior. Duodenum, second to fourth part. Pancreas, except till I have already told you, and all these structures, and you can see this is the peritoneum and all these structures behind it. Next, let's talk about omentum. So the peritoneum folds that are related to the stomach are called omentum. It can be less omentum or greater omentum. Less omentum is from liver to stomach and duodenum through hepatoduodenal and hepatogastric ligament. The greater omentum is from the stomach to the transverse colon, and the 4 layers of greater omentum, I have explained it in my previous video. The link will be up in the eye or in the description box. Do check this. And it hangs like an apron. So clinical aspect of a greater omentum is it is called the abdominal policeman. Why? Because whenever there is an inflammation or there is organ inflammation, so it wraps itself around that organ to prevent adhesion between visceral and parietal peritoneum. So it wraps itself around the inflamed organ. Next, mesenteries. Mesenteries are peritoneal folds that attach viscera to the posterior abdominal wall. So here we can see the peritoneal reflections of three main organs, that is the transverse colon, the small intestine, and the sigmoid colon. So the root of transverse mesocolon is just transverse, like just behind where the transverse colon is. The root of mesentery means the mesentery of small intestine. So the root of mesentery is from the duodenojejunal junction. You can see this was the duodenum, and this will be the duodenojejunal junction to the right iliac junction. So this is the root of mesentery, and this will be your sigmoid mesocolon, the root of sigmoid mesocolon. In this picture of monitor, it is more clear. Here you can see the root of transverse colon. It attaches to the pancreas. Now the root of mesentery, I told you it was from duodenum. This is duodenum, duodenojejunal junction to the right iliac fossa. This is the attachment of sigmoid colon. So you can see that these organs are completely covered by the peritoneum. These are intraperitoneal organs. While here you can see there is a fossa for, there is a site for descending colon and a site for ascending colon. They are not completely wrapped by the peritoneum. Now peritoneal ligaments about the liver, I have described it in the video of liver and stomach and spleen, and all these are the ligaments. And just a few pictures to show you the ligaments. The horizontal section to show you the gastrosplenic ligament, or the splenorenal ligament, or spleen is sometimes the Latin word for spleen is lien, L-I-E-N, so splenorenal ligament. And here you can see other ligaments, the gastrosplenic, the splenorenal or the splenocolic ligament, and same for here. Phrenicocholic for the diaphragm. Now lesser sac boundaries, it's not an interesting topic, but sometimes questions might be asked. So lesser sac, or the omental bursa is just behind the stomach. So anteriorly will be the caudate lobe of liver, lesser omentum obviously the stomach and the gastrocolic ligament. Now posteriorly will be the peritoneum covering diaphragm, pancreas, left kidney and duodenum. Also the transverse mesocolon. Now the left lateral, because you can imagine the left side, the spleen is in the left side, so the gastrosplenic or the splenorenal ligament in the previous picture I showed you, or in the right side there's the epiploic foramen. So the epiploic foramen of Winslow, it actually communicates, it's a communication between the lesser sac and the greater sac. So it is present on the right side, I'll show you in a picture, and superiorly we have liver. Now this is the basic kind of a diagram to represent the lesser sac, and you can see it has these pouches or these recesses. I told you that on the left side we had spleen and there is a splenic recess. On the superior side we have superior recess, on inferior recess, and epiploic foramen through which it communicates with the greater sac. And here are the recesses and its and more detail about it if you want to remember. Let's talk about epiploic foramen of Winslow. So anteriorly we have lesser omentum, also known as hepatoduodenal ligament. It is on the free edge of hepatoduodenal ligament. Posteriorly again we have peritoneum. Superiorly we have the caudate lobe of liver, and inferiorly we have the first part of duodenum and the hepatic artery. Let's see in this picture. So here is the epiploic foramen of Winslow. Through this, omental bursa communicates with the greater sac, and you can see it is present on the free edge of hepatoduodenal ligament. Now let's see hepatoduodenal ligament anteriorly. Superiorly we have liver, the caudate process, the caudate lobe of liver. Inferiorly you can see the first part of duodenum, and posteriorly inferior cava, the peritoneum covering the inferior vena cava. Now surgical importance of this foramen is that during cholecystectomy we can perform a Pringle's maneuver. In this, the surgeon puts the index finger inside the epiploic foramen and clamps the hepatic artery which is present in this hepatoduodenal ligament. You remember, hepatoduodenal ligament contains the portal triad. The portal triad is hepatic artery, portal vein, and the bile duct. And that's it for this video, guys. I hope it was helpful, and please like, share, and subscribe to my channel. Thank you for watching.